Hello guys, welcome back to my channel Memo African Motives, working on engineering, working on mathematics, that is for engineering, mathematics N1. So I'm going to work on the question paper which was written on the 8th of April 2021. Okay, so that's the question paper that we are having, and this 3-hour paper from 9 to 12, as you know. So if you are new to my channel, you can consider subscribing so that you won't miss any of the classes that we shall be having from Memo African Motives. Okay, so the first question, we are asked to simplify each of the exponents that we are given. Okay, so we got the first exponent. We're going to write down on 1.11. So we are given 4a to the exponent of 3, b to the exponent of 3, which is multiplying 5a to the exponent of 4, b to the exponent of 6. All right, so these guys, they are just asking you to apply the laws of exponents here. So what are we going to do? We are going to multiply the numbers together. So we've got 4 and 5, so 4 times 5 from a calculator, that is 20. All right, then on this part here, we've got the base and the exponent, the base and the exponent, or the base and the power. So we are going to add the power, so it's a to the exponent of 3 plus 4, because you're multiplying the bases which are the same, you add the exponents. Okay, you've got b and b, you're going to add 3 and 6, so it's 3 plus 6, you add the exponents. Okay, so you're going to obtain 20a to the exponent of 3 plus 4, which is 7, b to the exponent of 3 plus 6, which is 9. All right, so this is what we are going to have: 20a to the exponent of 7, b to the exponent of 9. So that is to simplify there. All right, then on 1.12, again we are given an exponent to simplify again. Okay, so let's see what we are given. That is the cube root. If you are to cross check, is the cube root of 27 x to the exponent of 3, which is multiplied to xy to the exponent of 3 and divided to x squared y to the exponent of 3, like that. All right, so let's see what we are having there. All right, sorry for that. So we are going to have, in this case, guys, which law are we going to apply? Take note, guys, from your laws of exponents that when you are given x to the exponent of a over b like this, it is going to give you base root of x to the exponent of a. So in actual sense, this can be rewritten in this form, which means 27 and x to the exponent of 3, this part here that we are having, is the same thing as writing it as 27 x to the exponent of 3 like this to the exponent of, since we are having a 3, it is going to be 1 over 3 like this. Okay, which can be taken as this 1 over n is the nth root of x, like that. Okay, on this part I'm not going to change anything, I'm just going to rewrite as it is, which is xy to the exponent of 3 divided by x squared y to the exponent of 3. All right, then applying the laws of exponents here, as you can see, this exponent is going to affect everything from this part here. If you are given mn to the exponent of a, is going to be m to the exponent of a, n to the exponent of a, like that. So that is what is going to happen. It's going to be 27 to the exponent of 1 over 3 x. Here we've got 3, so it's going to be 3 times 1 over 3 like this. All right, so take note, an exponent and exponent multiplies each other. Whatever that you're going to have here, you multiply it by xy to the exponent of 3 divided by x squared y to the exponent of 3. Okay, so 27 to the exponent of 1 over 3 you can obtain from your calculator, which is 3, or it simply means the cube root of what? Of 27, which is 3 from your calculator. So this is going to give you 3. 3 times 1 over 3 from your calculator is going to give you 1. So x to the exponent of 1 is same as what? X. So this is going to be 3x multiplied by xy cubed divided by x squared y to the exponent of 3, like that, which is y cubed. All right, let's see what you're having. We can apply the board mass or bomb dust, or depending with the way that you want. But actually here we are multiplying, so you're going to have yes same as 1. So it's 3 times 1, which is 3, x times x. This is x to the exponent of 1, x to the exponent of 1. So the bases are the same. You're going to add the exponent. So it's 1 plus 1, which is 2. So it's x to the exponent of 2, y to the exponent of 3. Okay, whatever that you're going to have, you divide by x squared y to the exponent of 3, like that. Okay, writing this expression that we have here is the same way as writing it as starting with the 3x squared like this, y to the exponent of 3 divide by, it's one and the same thing, you divide by this part, which is x squared y to the exponent of 3, like that. It's one and the same thing. So when it is like this, you can take an advantage that since these two are the same, you can actually cancel them. These two are the same, you can actually cancel them. So you're going to remain with 1. 3 divided by 1, which is 3 from your calculator. So everything is going to give us a 3 there. So as you can see, guys, when you are working with exponents, it's all about the laws and which law are you applying. That is what is best. Which law are you applying? As long that law is applicable, you can apply any law. You're going to obtain the same answer there. All right. On 1.13, we were asked to simplify again, and this is the expression that we are given, which is 1.13. We are given 4x y to the exponent of 3, which is divided by 8x squared y squared like this, then multiplied by 2xy to the exponent of s0, like that. Okay, so let's not waste much time. Just like I was explaining, when you are given a bracket like this, you are given mn to the exponent of a is going to affect everything. So this exponent will affect everything inside the bracket. So 4 is going to be affected to the exponent. This is same as 1, 1, 1. So it's 3 times 1, which is 3. 1 times 3, which is 3. So it's x to the exponent of 3, y to the exponent of 3. Everything is affected by this exponent. Okay, divide by, this part is going to remain as it is, so let's just write as it is, which is 8x squared y squared, multiply by, okay, this whole bracket, guys, take note, this whole bracket is raised to the exponent of 0, and we know that anything raised to the exponent of 0 gives us a 1, so we are going to obtain a 1, which is same as 1 times this is going to remain as this part alone. Okay, now at this stage, what am I going to do? Just from the previous part, we know that we can divide this like, okay, let's simplify first. 4 to the exponent of 3. So remember, 4 to the exponent, you can obtain this from your calculator, which is 64. That is 4 times 4 times 4. But from your calculator, you can obtain this as 64. So we are going to have 64 x to the exponent of 3, y to the exponent of 3, everything over 8 x to the exponent of 2, y to the exponent of 2. Since this times 1 is going to remain as it is. All right, now let's see what you're having at this stage. So at this stage, you can divide from your calculator. 64 divided by 8 is going to give us 8. Okay, so we're going to have 8. Then here you are dividing, the bases are the same, so you can subtract the exponents. So it's x to the exponent of 3 minus 2. So 3 minus 2, that's 1, which is same as x. The same thing here, we are going to subtract the exponents because the bases are the same. So 3 minus 2, that's 1, which is going to be y. So everything is going to be 8xy, like that. Okay, so that's how you were supposed to apply this type of equation. Okay, so let's see another one. Simplify each of the logarithms. All right, so logarithms, the best part that you are supposed to know again, because there is nothing on logarithms. It's all about the laws of logarithms only. That is what you need to know. All right, let's do this, guys. We are given a log expression that you have, and you want to simplify, and you've got 3 marks for that. The first thing, we know that when you are working with logarithms, when you are adding logarithms, you multiply the numbers. Log m plus log n. Provided the bases are the same, you're going to multiply the numbers, which is log mn. So it's m times n. So here we've got 25 and 4. The base are the same. If the base is not given, it means you are in base 10. So this is same as you are in base 10. So you can multiply the numbers together. That is 25 times 4. Okay, let's subtract log 10. We are going to talk about this later on. So 25 times 4 is the part now that you are left with, that you are supposed to use your calculator. You're going to obtain 100. So this is going to be log 100 minus log 10. So here there were two options that you could have used. The first option, you can apply the laws of logarithms. Since the bases are the same, you can divide, since we know that log m minus log n gives us log m over n, like this. So like I said, we've got two options, so let me write them. The first one was to divide. You could have divided the numbers there, which is log 100 over 10, provided that these numbers are under one logarithm, like that. And if you divide 100 divided by 10 gives us 10, so it's going to be log 10. Okay, we are in base of 10 in this case, and we know that logarithm from our laws, logarithm of a number in base of that number gives us 1. If you are given a and a, your answer is going to be 1. So logarithm of 10 in base 10 is going to give us a 1. So which means everything in this case was going to give us a 1. That was the first option. Or you could have simplified this part first. Log 100, because this is in base 10, and log 10 in base 10. Okay, already let's simplify. This is a minus. Already we said log 10 base 10. We simplified log 10 base 10. We said it's a 1. You simplify log 100 base 10. How do you simplify logarithm of 100 in base 10? We have two options. We can say let logarithm of 100 in base 10 be equal to x. That will be 100, the number, is equal to the base of 10 to the exponent of x, so that you can calculate the value of x. So how can I calculate the base of the value of x? I have to make sure that these bases are the same. So 110, 100, we know that it's 10 times 10, which is 10 squared. So it's 10 to the exponent of 2, which is 10 to the exponent of x. Why are we writing in the bases which are the same? Because we know that when the bases are the same, the exponents are also the same. So therefore x is equal to 2. So in this case, logarithm of 100 in base 10, which is equal to x, is giving us a 2. So you can substitute in place of logarithm of 100 in base 10, you've got a 2. So 2 minus 1, which is a 1. So as you can see, we are obtaining the same answer with 1 who applied this option. From this step, you can opt this way, or you can opt this way. So these are the two options that you can actually apply. So it depends, guys, with the one that you actually want to use, but that was the idea there of the question. So as you can see, these are pretty easier questions that you just need to know the laws there. All right, let's see another one on 1.22, where you are asked to simplify again the logarithm, and that one is got 4 marks to make it 15 marks everything. So as you can see, guys, these are a lot of marks. 15 marks in exam. These are a lot of marks that you can actually obtain, or that you can actually have there. So depends with what you want, guys. Do you actually want to obtain these marks? Or all right, so that one is log. There's just law is supposed to be log, like that. Okay, just a typing error. Okay, this is where we are, guys. Again, we've got two options to multiply and simplify the logarithms, but as you can see, guys, you can just apply, simplify this one, simplify this, and just write them. Okay, so let's simplify them separately. Logarithm of 64 in base 2. So like we did from the last part, we're going to let log 64 in base 2 be equal to x. Remember the concept, guys. So 64, this number is going to be equal to the base to the exponent of the answer, which is x. So it's 2 to the exponent of x. Okay, so which number are we going to use in base of 2 to raise to give us a 64? So 64 from your calculator, this is 2 to the exponent of 6. 2 to the exponent of 6 from your calculator gives you 64. It's only that I'm having too much light, that is why I'm not showing. Let me just show from this part like this. 2 to the exponent of 6 like this, you're going to obtain 64. All right, so that is the concept there. So which is equal to 2 to the exponent of x. So the bases are the same, therefore the exponents are the same, so x will be equal to 6. All right, so in place of log 64 base 2, I can substitute this with a 6 plus log 16 base 2. I do the same. Let log rhythm of 16 in base 2 be equal to x. So some of these you might know them by head. You can just write the answer. Okay, so 16 is equal to 2 to the exponent of x. The bases should be the same. So 16, which base 2 to the exponent of 4 gives you 16, which is 2 to the exponent of x. So the bases are the same. X is equal to 4. So in place of log 16 base 2, our answer is 4. So I'm going to substitute here. In place of log 16 base 2, I'm going to substitute with 4 over. So it's not log 4, it's just a normal number 4. You have replaced a log with its numerical value or its equivalent value. Okay, you do the same. Log 8 base 2, you just simplify, just like what we did there. Log 8 base 2, let it be equal to x. So just the normal way, 2 to the exponent of x, 8 is equivalent to 8. The number here is equivalent to base to the exponent of x. Okay, so 8 in base of 2, that's 2 to the exponent of 3, which is 2 to the exponent of. So this number from your calculator is going to give you 8, which means it's one and the same thing. So once the bases are the same, the exponents are the same. So x is equal to 3. So it means log 8 in base 2 is equivalent to 3. So I can substitute here. In place of log 8 base 2, I've got 3 minus log 2 base 2. We are back to that law that we applied last time of log a base a, which gives us a 1. So this one is going to give us a 1. All right, so add, or you can just use your calculator at once, or you can just add 6 plus 4 from your calculator. This is 10 over 3 minus 1, which is 2. Okay, so if you divide properly, you are going to obtain a 5. So that is the resultant there, or you can just divide this at once from your calculator. It's going to give you the same thing. What you just need is to put your fraction properly. Okay, so make sure that your fraction is visible like this. You put your fraction, so it's 6 plus 4 over 3 minus 1. All right, which is a 5. So as you can see, we are obtaining the same thing, which is a 5. So that was it, guys, to make it 15 marks on question number 1. So these are a lot of marks, guys, in exam that you can't afford to just lose or to leave an exam. All right, add the following polynomials. Okay, we are given 2 polynomials that you're supposed to add. Guys, to add is just to add. Yeah, isn't it? To add is just to add. Okay, so this is the first polynomial. I'm going to put it in a bracket, plus I'm going to put also this in a bracket, plus I write that polynomial as it is, minus a plus 6b minus 55. It's best for you to write this in a bracket. Okay, why? Because sometimes you might be subtracting, and when you are subtracting, the sign is going to be affected very much. Okay, anyways, there is a 1, so this bracket is going to remain as it is because you are affecting by a 1, so there's no effect. 7a minus 4b plus 3, plus and minus, plus does not change anything, so it's going to remain as minus a plus 6b minus 55 like this. Okay, then you collect like terms, so you've got 7a and minus a. This is same as 1, so it's 7 minus 1, which is 6a. You've grouped like terms. You've got b minus 4 and plus 6, so it's minus 4 plus 6 from your calculator is 2, so it's 2b. 3 minus 55, these are the like terms, so 3 minus 55 from your calculator, this is going to give you minus 52. So you're actually doing nothing there, you are just applying your calculator. So it's a principle where you have to rearrange your numbers in a proper way, collect your like terms, but that is the idea that you're having Okay, so as you can see, this one now is the issue of brackets. You are going to see the issue of brackets here because you subtract this from. So take note when they are saying from, which means this is the one that is subtracting this expression, this part from, like this guy. Let me express in terms of numbers. 2 subtract 2 from 5. Subtract 2 from 5. It means 5 minus 2. Subtract 3 from 7. 7 minus 3. Okay, so in this case, it's subtract this now, this expression from this expression. So you're going to start with this expression, okay? The second expression, this is the one that you're going to start with. And it's minus 3x squared plus 2x minus 1. You just write it in a bracket like that. Subtract, I'm going to subtract like this. What part am I subtracting? I'm subtracting this expression here. So I'm going to write it in a bracket as it is again, which is minus 5x squared minus 3x minus 2. So that is what we had. Subtract this from this expression. All right. Now at this stage, what am I going to do? Expand the bracket so that, as you can see, this is a 1. So there's nothing. This bracket is going to remain as it is, which is minus 3x squared plus 2x minus 1. But this bracket is going to be affected by a negative. Take note now, because of a negative, everything is going to change. So it's negative and negative, that's a plus. So it's plus 5x squared. Negative and a negative plus 3x. Negative and a negative plus 2. All right. So let's collect like terms. We've got minus 3x squared plus 5x squared. 2x here plus 2x, 3x here plus 3x. We've got minus 1 and plus 1, so it's minus 1 and 2 there, plus 2. So these are your like terms. So using your calculator, minus 3 plus 5, that is 2. So you're going to obtain 2x squared. 2 plus 3, that is 5. So you're going to obtain 5x minus 1 plus 2, which is plus 1. All right, so this is what you're going to have at the end. So take note, guys, you are just simplifying. You are just simplifying. So it's a matter of expanding brackets. After expanding brackets, collect like terms and simplify properly by adding or subtracting. Okay, so that's what we had on this part. Let's see another question that we had on 2.3 to simplify. What are we simplifying? What are we doing there? On 2.3, we are given 4a, the bracket, 4a, is it 4a? Yes, that's 4a minus 3 to the exponent of 2. And we've got 3 marks for that. Okay, guys, these guys, we are just playing with us here. When you're asked to simplify like that, it means you have to expand. Squared, a squared, just like 4 squared, it means 4 times 4. So when a bracket is being squared, it means this bracket is multiplying itself like this, just like what the number was doing, 4 times 4. So it means this bracket times this bracket, that is the square when it is affecting a bracket. Okay, so let's expand the bracket. 4a is going to multiply 4a, so it's 4 times 4 from your calculator, that's 16a squared. Remember, a and a gives us a square, is 1 and 1, so it's going to be a squared. You are done with 4 and 4, so you move on to 4 and minus 3. So 4 times minus 3, that's minus 12a, because there's an a there. You are done with 4a. You move on to minus 3, so it's minus 3 and 4. So minus 3 times 4, that's minus 12a. Minus 3 and minus 3, so minus 3 times minus 3, that's a plus 9. Okay, you're multiplying there. So collect like terms. Already the like terms, they are written here. They are there in this case here. Minus 12 from your calculator, minus 12 is minus 24. So it's going to be minus 24a plus 9. So we have expanded brackets. To expand brackets, you just leave your answer like that. When you put brackets back like this, it's now factorized. You're now factorizing. That would be factorization. But to expand, is the opposite of factorization. So to put in brackets, you are factorizing. To expand brackets, you are now removing the brackets. That is when you are given a bracket. To simplify, you are actually removing the bracket. Okay, then factorize. Fully factorize each. Okay, we are asked to fully factorize each of the given expressions. Okay, on 3.11 we are given 2x to the exponent of 3 minus 6x squared plus 10x. Okay, someone might wonder what is happening here. How can I factorize this type of an expression? There is an exponent of 3. Okay, don't be scared about that 3. The first thing, guys, when you are factorizing is to look into the expression. Is there any part that is common throughout the expression? So let's check, guys. We've got 2, 6, and 10. So 2 is a factor here, so I can factor out 2. I've got x to the exponent of 3, x to the exponent of 2, and x. So which means x is common, and the least power is the one with x. So 2x is very, very common throughout there. So I can start by factoring out 2x. Okay, so let's factor out 2x. So it's 2x to the exponent of 3 divide by, this is how you factor out. You are simply dividing like this. 2x to the exponent of 3 divide by 2x. So 2 and 2 cancel. X into x to the is x squared, or is 3 minus 1, which is 2. So you're going to remain with x squared. Minus 6x squared divide by 2x. So it's like this. Minus 6x squared divide by 2x. So it's 6 divided by 2, which is minus 3. X, this one is going to subtract 2 minus 1, which is x to the exponent of 1, which is same as what? Minus 3x. So the part that you factor out is the one that you divide back here. So it's 10x divide by 2x, the part that you, so if you divide, what are you going to have? 10x divide by 2x like this. So x and x will cancel. 2 into 10, or 10 divided by 2, that is 5. So you're going to obtain plus 5 like this. All right. I have factored out 2x, but this is not enough. Why? Because inside this bracket, I'm left with a quadratic expression. So what am I supposed to do with this quadratic expression? Supposed to factor it out. So the advantage is that the coefficient of x squared is a 1. So I can just open two brackets. Remember, you have your x and your x here from your factorization. You're going to focus with the last term, which is the constant, which is 5. What are the factors of 5? But these factors of 5, when you add them, they must give you a negative 3. So you need factors of 5 there, but when you add these factors, they are going to give you a negative 3. Do we have such factors? That is the question. All right. So if I am to cross-check here, you do not have the factors actually, because the numbers that you can multiply to give you 5, it's 5 and 1. These are the only numbers that we have. Take note, guys, this is a 5 and this is minus 3. So we have 5 and 1. So there is no condition that I can multiply this, obtain 5, or minus 5 and minus 1. But if I add these, I can't obtain this negative 3. So what does it mean? It means this part cannot be factorized further. So your resultant is going to remain as 2x into x squared minus 3x plus 5 like this. So this is going to remain as your final answer. You can't factorize that part. So that's it. Sometimes they can give you a part that you can actually factorize further, but in this case that's what we had, and there's nothing. So you have to try. You can't just factorize like this then you leave it. You have to try, is it going to be proper? No. If not, no, then you leave it. You write your final answer. So this is going to be the resultant. Okay, so that was it, guys, for this question. Sometimes you have to try everything. Okay, on 3.12 we've got 4 marks for that, to factorize that expression on 3.12, which is 3x squared minus 3x minus x plus 1. Okay, so remember, when you are factorizing and when you're given 4 terms like this, we've got 1, 2, 3, 4 terms. Yes, it's a quadratic, but it has got 4 terms. This one, you're going to factorize it by grouping. You group your terms. So you're going to group them into 2 like this. You separate them into 2. So you factor out for the first 2 terms what is common. So you've got 3 here is common, we've got x squared and x, so x is common, so that is your highest common factor. So you factor out for the first two. So what are we going to do? Just like what we did is 3x squared divide by the part that you factored out, like this. 3x squared divide by 3x, so 3 and 3 will cancel. X squared divide by x, this one with 2 minus 1, which is x to the exponent, which is what? X. Minus 3x divide by 3x, like this. Minus 3x divide by 3x. So as you can see, 3 and 3 will cancel, x and x will cancel, you are left with minus 1. All right. On the other part, that is where most of you guys, you lose marks on this part here. Take note here, it's minus x plus 1, and we are supposed to obtain a bracket which is the same as this bracket. They must be the same. So what can you factor out here so that the bracket will be the same as this one, which is x minus 1? You are going to factor out negative 1. So that minus and minus gives you a plus. Plus and a minus gives you a minus, like this. So once at this stage, when these two brackets are the same, you factor out this common bracket, which is x minus 1, like this. So once you factor out this common bracket, what is going to remain? You are going to remain with 3x on this part, and on this one, you are going to remain with minus 1. So like this, this is going to be your resultant answer. That is going to be your answer there. You have factorized that expression. So that's it, guys. That's how they play around these questions. Okay, let's see on number 3.2. Simplify. Okay, that's the whole expression that you're given to simplify, and it's 4 marks for that. How can I simplify 4x into x minus 3 to the exponent of 2 plus 2x plus 4, like this, to the exponent of 2 minus x squared minus 3x plus 2. So they're just playing with us here, guys. What are they testing you? They're testing you. Can you expand these brackets? Yes, we can. So let's expand 4x. Remember what we said, guys. Squared means you've got two brackets, x minus 3 into x minus 3, like this. Okay, plus we've got another part that you're going to expand, two brackets again, 2x plus 4 into 2x plus 4, like this. All right, then we've got minus this part. Let me just write as it is. I'm going to talk about it later on this part. All right, so this is the stage where we are. So no ways we have to expand. There's no way. Let's expand this separately, these two brackets, x minus 3 into x minus 3. Let's just expand this aside, like this. So it's x into x, that's x squared, x times x into minus 3, which is minus 3x. Okay, we're done. We are moved on to minus 3. So we are done with x, we move to minus 3. So it's minus 3 and x, minus 3x, minus 3 and minus 3, which is plus 9 from your calculator. Okay, collect like terms. So it's going to be x squared minus 3 from your calculator. This is minus 6x plus 9. All right, so you've got x squared minus 6x plus 9. So it's going to be 4x into this part that we obtained, which is x squared minus 6x plus 9, like this. All right, you do the same, plus you expand these two brackets. All right, so now what do we have? 2x plus 4 into 2x plus 4. These are the two brackets. All right, so let's expand 2x and 2x, that's 4x squared. All right, so 2 and 2, that's 4x squared. 2 and 4, that's 8x. So it's going to be 8x. You're done with 2x. You move on to 4 plus 4 and 2. So it's going to be 4 and 2, that's 8x. 4 and 4, which is 16. That's how you expand. Okay, then you collect like terms. So it's 8 plus 8, 8x plus 8x, 8 plus 8, which is 16. So it's 16x plus 16, like this. So this is what you're going to obtain from this bracket, which is plus 4x squared plus 16x plus 16. That is what you obtained from this bracket. Okay, then on this one, let's now expand this bracket. What are we using? A minus. So it's minus times x squared, which is minus x squared, minus times minus 3, minus and minus, that's plus 3x, minus times plus 2, minus and the plus, that's minus, so it's going to be minus 2 like that. All right, interesting stage. Then we are going to collect like terms, expand and so forth. So this part we have to expand the brackets, so it's 4x and x squared. Take note, this is x squared and x, so it's going to be 4x to the exponent of 3, because this is 1 and 2, so you add 1 plus 2, which is 3. When you're multiplying the bases which are the same, you add the exponents, okay? 4x times minus 6, which is minus 24x squared, so it's 1 and 1, which is x squared. 4x times 9, this is going to give you 4 and 9, that's 36x from your calculator. You just multiply 4 and 9, which is 36, but there's an x, which is 36x, okay? Then, on this part, we can actually collect like terms and simplify. So it's 4, and here it's 1, 4x squared, and minus 1x squared. So it's 4 minus 1, which is 3. So it's plus 3x squared. 16x, it's plus 16x and plus 3, so it's 16 plus 3 from your calculator, which is 19x, okay? 16 plus 16 minus 2, so 16 minus 2 from your calculator, that's plus 14. All right, let's move on. Collect like terms again, because as you can see, it's now a matter of collecting like terms. So this 4x to the exponent of 3 is no like term, so it's going to remain as it is, 4x to the exponent of 3. You are left with this part. There is minus 24x squared plus 3x squared, so it's minus 24 plus 3, so which is minus 21 from your calculator, minus 21x squared. 36 plus is 36x plus 19x. Take note, so x and x, so it's going to give us 55, if I'm not mistaken, that's 55x. All right, plus 14. 14 is nothing to add, there is no number, all the numbers have been used, so it's just going to be 14 like that. All right, so very interesting question, guys, that we actually had on 3.2 on simplifying. So someone might wonder, how are we supposed to simplify? Okay, so these are the stages that you're supposed to take. So as you can see, guys, it's a matter of applying the concept that you understand mostly. This question is actually a pretty question that I want you to understand its basics. Okay, so I want you to understand this part, guys. I'm just going to list down this. I will explain in a better way that you can actually understand this part forever. When you are working with HCF and LCM, there is nothing at all. Nothing at all. All right, these were the expressions that we were given actually. All right, so when you are working with the LCM, because the first part was the LCM, take note, guys, find the lowest common multiple, which is LCM, and so we are going to start with LCM. Okay, so when you are working with the LCM, the first thing, sometimes they can give you numbers that you can actually expand. So in this case, there is nothing that you can do on 7 and 5. 7 is just 1 times 7, 5 is just 1 times 5, but 8, the factors of 8 is actually 2 times 2 times 2. If you multiply these numbers, you're going to obtain 8. How do you determine these numbers? Actually, let's just do this using t. So I'm just going to divide 2 into 8, that is 4. The smallest number is 2. I use the smallest number, 2 into 4, or 4 divided by 2, that is 2. 2 divided by 2 again, which is 1. So these are the numbers. Okay, so the LCM, I want you to listen carefully, guys. For the LCM, when you are working with the numbers, you are going to take every number that appears. When you are working with letters, it's the same thing. You're going to take every letter that appears, that is there. So you've got 1, but 1 is no effect, so this one is no effect, this one is no effect. So you've got 2, 2, and 2, which is actually 8, because if you multiply these numbers, they're actually giving you 8. 2 times 2 times 2, it's actually this 8. Times, we have got 5, it's a number that is appearing, you multiply it, you've got 7. It's a number that is appearing, you multiply it. So LCM, you take everything. Take note, LCM, you take everything. Okay, multiply by, you move on to the letters. When you are working with the LCM, you take a letter that has the highest exponent. The letter with the highest exponent for LCM. So which letter is the highest exponent in terms of x? It is this x to the exponent of 5. Okay, for y, which one is the highest exponent? It's y to the exponent of 6. In terms of z, which one is the highest exponent? It's z to the exponent of, you take the one with the highest exponent. Okay, now let's multiply the numbers. So you can actually multiply these numbers together using your calculator. As you can see, this is, like I said, you can write it as 8. Okay, so you're going to obtain something like 280. Okay, 280 x to the exponent of 5, y to the exponent of 6, z to the exponent of 5, like this. So this becomes your LCM. So if you multiply these numbers properly, that's 280 for you. All right, so guys, that's the idea there. Okay, then the highest common factor, which is the HCF. This one, guys, it's a factor. A factor is supposed to be common throughout. So this one is common throughout. Is the spelling, or I'm writing it wrong, but something like that. It's supposed to be common throughout. Okay, so if it is supposed to be common, therefore what am I going to do? Let's start with the numbers here. Which numbers? There is no number that is common. We've got 7, 5, 2. There is no number that is common. So on numbers, there's nothing. I move on to the x. X is common throughout, y is common, z is common. But I'm going to take the one that is, okay, the least exponent this time for the HCF. So I'm going to take the one with the least exponent. So that means my HCF is going to be, in terms of x, which one is the smallest, the least? I'm referring to the smallest exponent. So the one with the smallest exponent is x to the exponent of 1, this one, which is what? Which is x. Okay, we move on to y. Which one is the smallest exponent? Is y, and also for z it's z. So it's going to be x, y, z. That is your HCF. So in terms of numbers, we do not have any number that is common here. There is no factor. There is no factor of 7, which is a factor of 5, which is a factor of 8, unless you're talking of 1. So 1, you can't write 1 there. So you just leave it like that. So that was the idea there. So that is the HCF. HCF is supposed to be common throughout, and you take the one where the smallest or the least exponent. All right, on number 4, we are now given to solve the equation. So you start by looking at the equation. What type of an equation am I given? This is a linear equation. When you are referring to a linear, you are referring to the one where the highest exponent is 1. The highest power there is 1. Okay, so we are given 5x plus 3, which is equal to 24 minus 2x, like this. You want to solve this equation. So how can I solve this equation? It's all about grouping like terms. So I'm going to take this x to this 5x. All right, so what am I going to have? I'm going to have 5x minus 2x to this side is going to be plus 2x, like this. All right, then we can actually transpose. In this case, we can actually transpose this 3 to this side, so it's going to be minus 3. Okay, so we're going to be having 24 minus 3. Take note, when anything crosses the equal sign, it changes its sign. Anything crosses the equal sign, it changes its sign. So let's see what we're going to have. We can add 5 plus 7, 5 plus 2, that's 7. Oh, I'm rushing, which is 7x is equal to 24 minus 3. From your calculator, this is 21. Okay, so how can I obtain x? These two, they are multiplying. So to remove this 7, which is multiplying, you divide. So you're going to divide by 7. So divide by 7, x is equal to 21 divided by 7. From your calculator, this is going to give you a 3 there. So that's how you were supposed to answer this question. As you can see, you've solved. Solving for x, you're actually finding the value of x. Okay, 4.12 solve for x again, but which is 4.12. okay, this is 4.12, not 4.11, 4.12. so if you are to cross check that part here, let's just write it down. Maybe it's gonna be best way of doing it. That is 4x plus 6 like this. Okay, so this is the equation that they are asking you to solve. All right, so let's do this, guys. Let's just expand. I think it's gonna be the best way for us to reach out the answer. So we are going to expand by 8 here. So it's 8 into 1, that is 8. 8 into minus 3x from your calculator, this is minus 24x, which is equal to 5 into 4, which is 20x. 5 into 6, which is a 30. Okay, then just like the previous part, guys, you have to collect like terms. So depending with which part are you going to take, you can collect anyway. Okay, so I can choose to remain with this negative 24x here and transpose my 20 to this side, so it's going to be minus 20x. So it's going to be minus 20x, which is equal to, already I had a 30 on this side, so I'm going to remain with 30. Then transpose 8 to this side is going to be minus 8. Okay, then simplify this part from your calculator. Minus 24 minus 20, which is going to give you minus 44x, which is equal to 30 minus 8. From your calculator, you're going to obtain 22, like that. Take note, guys, this is going to give you 22. So to find x, what am I going to do? You divide by negative 44 here, you divide by negative 44 here. All right, so these two cancel, you've got the value of x. So if you use your calculator properly, this 22 over minus 4 minus 44 is going to be minus 1 over 2. This is the value of x that you're going to have, or someone can write this as a decimal, which is minus 0.5. So that's it, guys. That's, as you can see, it's a pretty nice question that you had there. Okay, 6 times the sum of 8, 6 times the sum of 8 and a certain number equals 6 to determine the uncertain number. Okay, we are given that 6 times the sum of 8, take note, the sum of 8 and a certain number. Okay, so you have got 8 and a certain number. 6 times means you're multiplying, so it's 4.2 like this. This is our attempt. So it's 6 times, which means you're multiplying, so you can open a bracket like this. Okay, the sum you are adding. What are you adding? 8 and a certain number. So we don't know this number, we can just write it as x. So it's 8 plus x, that is the sum. Okay, so 8 plus x, this 6 times is going to give us 60. So our answer is 60 like this. What is that uncertain number, which is x? What is the value of x? So they're asking you to solve for x. So you've got two main options. You can choose to expand brackets, or you can divide by 6. It's up to you. So you can multiply by 6, 6 and 8, that's 48, plus 6 and x, which is 6x, which is equal to 60, like that. All right, collect like terms. So I'm just going to remain with positive 6x on this side. 6x is equal to, I transpose this to the right hand side, is going to be 60 minus 48. Okay, so that is what we are having from this part. So what can I do from this part? Definitely I have to subtract. 6x is equal to 60 minus 48 from your calculator, which is going to give you something like 12. Okay, then to find x, since this is multiplying, divide by 6, divide by 6. So x is equal to 12 divided by 6, which is 2. So that's what we had there. So as you can see, guys, it's a matter of playing around numbers. That's actually how you can solve. Okay, another question, still on on question 4. We have 4.3, where we are given we are given this equation. It's actually an equation there. So let me just write it and see what we are asked to do. Is 2px like this minus 3 is equal to 4y minus 3p like this. That is what you're given. And from this equation, you're asked to make p the subject of the formula. Make p the subject of the formula. Okay. So I want to make p to be the subject. So I'm just going to, right, we want to make p to be the subject there. Okay. So the first thing, we are going to collect terms with p to one side of the equation. So let's collect terms with p, just like what we're doing when you're solving. Collect terms with p to one side of the equation. So it's going to be 2px minus 3p to this side is going to be a plus 3p, like that. All right. So these are the terms with p, which is equal to all other terms without p to the other side of the equation. Already there was a 4y which was there. Then you transpose this negative 3 to this side is going to be a plus. So it's going to be plus 3. All right. Then, yes, we have collected the terms with p to one side of the equation, but as you can see, we've got p here and we've got p here, which is common. So I can factor out this p. So here I have to factorize. So if I factor out p, I'm going to remain with 2px divided by p, which is 2x. 3p divided by p is going to be p and p cancel, and remain with 3, which is equal to 4y plus 3. All right. Then how can I make p to be the subject? How can I remain p? I have to divide by the bracket. Okay, so this part, divide by the bracket, divide by 2x plus 3, divide by 2x plus 3, like this. So once you divide by this bracket, you are remaining with p. So therefore p will be equal to this expression, which is on the right hand side, which is 4y plus 3 over the bracket of 2x plus 3, of which you can just write it like that, 2x plus 3. Okay, so that was the idea, guys, on making p the subject of the formula. Okay, if x is equal to 5 on 4.32, if x is equal to 5, y is equal to minus 2, calculate p. Okay, so here we can just substitute. Already p is the subject, so it's now a matter of substitution. So this was 4.31, where you're to make p the subject. Okay, so on 4.32 there, we are given the value of x, which is 5, the value of y, which is minus 2, and we want to calculate the value of p. So you can just substitute. P is equal to, already we are given this equation here. So I'm just going to substitute in place of y. I'm going to substitute y is minus 2. So 4y means 4 times. So it's going to be 4 times minus 2. That's open a bracket like that. Plus 3. Okay. Plus 3 over 2x plus 3. So it's 2 into x. X is 5. So it's 2x, which is 2 into 5 plus 3, because there's a plus 3 here. All right, so that's what I'm going to have. So you can actually use your calculator, because it's just 2 marks here. So you can simplify this, or you can use your calculator at once. If you want to simplify stage by stage, we are going to obtain minus 8 plus 3 over 2 times 5, which is 10 plus 3. Minus 8 plus 3 from your calculator, this is negative 5 over 10 plus 3 from your calculator, this is 13. Or you can just simplify this at once. So that is it, guys, by calculating the value of what? The value of p. We have calculated the value of p from this expression. Okay, on number 5, we are given the equation of a straight line graph is given as, so we are given the equation of a straight line graph, which is y is equal to minus x minus 3. Okay, this is 5.1, we are given the equation of a straight line, which is y is equal to minus x minus 3. Okay, so the first question is, right, what is the gradient? In fact, we are not asked to calculate, you are given what is, which means you're supposed to state the gradient. Okay, so the gradient there is minus 1. How do I determine the gradient? Because I know that when I write the equation in the form of y is equal to mx plus c, this m represents the gradient, which is the number that is affecting x. So in this case, you are given y is equal to minus x plus minus 3 like this. So there is minus 1 here. So the gradient is minus 1. So that is the value of gradient, which is minus 1. Okay, so that is 5.11. Okay, then on 5.12, you are given also write down the constant number. So the constant is the one that is not having a variable, which is this minus 3. Okay, without a variable, this one minus 3, that is your constant. So the constant there is minus 3. All right, that's what we were given there. So the other part now is complete the table of the graph of y is equal to minus x minus 3 on answer sheet here. Okay, so we want to complete this table. Okay, so actually here you are given the part that you're supposed to complete here. So what are you going to do? You're just substituting here. In place of x, you substitute minus 2 minus 1 is 0. Okay, so that is what you're going to do. Okay, so let me show you guys what you're doing here. Y is equal to minus x minus 3 like this. So you substitute. I don't know what's trying to happen now. So you're going to substitute. The first value here is minus 2. So this is the value that you're going to substitute in place of x. So you're going to substitute like this. In your calculator is supposed to be like this. Y is equal to minus, which was there, this minus, and x, which is minus 2 like this, then minus 3. This is what you are supposed to indicate or to have on your calculator. Okay, so you are going to obtain negative 1 if you do that. Okay, so this is going to give us negative 1. Okay, let's hope this is not going to affect our question on the other side. Okay, when x is minus 1, we do the same. In place of x, you put minus 1. So it will be y is equal to minus for the formula, but your x is minus 1. So it's minus 1 minus 3. So you're going to obtain from your calculator, that will be minus 2. So this is going to give us negative 2. Okay, when x is 0, you do the same. So this one, we say it's minus 2. When x is equal to 0, you do the same. So it's minus 0 minus 3. Okay, from your calculator, this is going to give you minus 3. Okay, so that's minus 3. When x is equal to 1, you do the same. In place of x, you put 1. So it will be minus 1 minus 3 like this. In place of x, you put 1. So y is going to be minus 1 minus 3, which is minus 4. From your calculator, just use your calculator. Okay, so this will be minus 4. And when x is equal to 2, you do the same. This one will be 2. So it will be minus 2 minus 3, which is minus 5. So these are the values, guys. Okay, then you've completed the table. What's the next thing? Sketch the graph now. So this part is sketch the graph of the table completed in question 5.13, which is this one, the straight line on the answer sheet attached on question 3, or that is 3 marks there, sorry. So we are going to draw the graph now. How am I going to draw the graph? Okay, so this one is a straight line graph that we are given. So we are just going to mark the points that you are given. So this is according, as you can see, this is minus 2 minus 4 minus 8 1 2 3 4 minus 1 minus 2 minus 3. So it means this is 1, this is minus 1, sorry, this is minus 2 minus 3 minus 4 minus 5. Okay, this is 2, so which means in between you've got 1 2, that's 1 2 3. So this is going to be 3 4 here, and this is 5, and this is 6. Okay, so you've got minus 2 minus 4 minus 6. This is minus 6, not minus 8, minus 6, and this is positive 6. So you are supposed to analyze your scale first. Okay, now you can mark your points. So where minus 2 and minus 1 meet, 2 for minus 2 in x, minus 1 in y. So this is your x-axis, this one, minus 2, and minus 1 in y. This is your minus 1 in y. Where these two meet, you mark a point. So this is minus 2 minus 1. You mark a point. Okay, you move on. Minus 1 and minus 2. X is minus 1, y is minus 2 at this point. You mark a point like this. Okay, 0 and minus 1. When x is 0, it's minus 3. 0 and minus 3. you mark a point that's 0 and minus 3. Okay, 1 and minus 4, you've got 1 and minus 4, you mark a point again. Then 2 and minus 5, I don't know where do they wanted us to mark because it's not there. So actually that's it, but now you can just join the points. Okay, so you must produce a straight line there like this. All right, so that is the straight line that you are supposed to have there. Okay, so you write down the equation, which is y is equal to minus x minus 3. So that was what you were given there. All right, so let's see the other part that we are given, which is on 7.2. Y is equal to 7 over x. Complete the following table on answer sheet 1 attached. Okay, so it's the same thing like what we did from the previous question. So you've got the values here, so you're just going to substitute into x, just like what we did. Okay, so this is what we are going to do. So the equation, remember the equation, it's y is equal to 7 over x. Okay, so when x is minus 7, so it's 7 divided by minus 7 like this. So it's supposed to be y is equal to 7 over minus 7. This is going to give you negative 1. So you've got negative 1. When x is minus 1, so y is going to be 7 divided in place of x minus 1. So you're going to obtain minus 7. Okay, so that is the concept. This one is going to give you minus 7. This one is going to give you a 7. And this one is going to give you a 1. All right. So that was the concept. You just substitute in place of what? In place of x here. So 7 divided by 7, 1. 7 divided by 1, that's 7. Okay. Then draw the graph of y is equal to 7 over x on answer sheet attached also. All right. So we are going to mark the points just like what we did from the previous question, but you have to analyze again. So here these were 5 boxes. I don't know if they are going to be clear, but these were 5 boxes representing a 5, like 1, 2, 3, 4, 5. Supposed to be 5 like that concept. That's 1, 2, 3, 4, 5, 6, 7. So I'm just going to use this is 1, 2, 3, 4, 5, 6, 7. Minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7. Okay, then the same thing, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7. The same thing here, 1, 2, 3, 4, 5, 6, 7, like that. Okay, so that is what is supposed to be look like. Let me just try to adjust. All right, something like this. Let's hope it's clear. Yeah, something like that. Okay, so these are the points that we're going to have. Then you mark them, minus 7 and minus 1. So x is minus 7 here and y is minus 1. So you mark this point here, minus 7 and minus 1, just below minus 7, minus 1 and minus 7. So this is minus 1 and minus 7 here. You mark a point here. Okay, we have got 1 and 7, 1 versus 7, which is here. You mark a point. Your x is 1 and your y is 7, so they meet at this point. Then you have got 7 and 1, which is at this point. X is 7 and y is 1 at this point here, something like this. Okay, so looking at the type of the graph that we are given, y is equal to 7 over x, we know that this one is supposed to be an inverse function like this, supposed to be like that. Okay, so you are going to just join these points. It's not a straight line, it's a free end graph that you're going to do, something like this. It approaches this line until it reaches this point here. It tries to approach to 0, but it will not approach that, something like that. So a curve like that. All right, it's only because of the way that I'm sitting, but it's supposed to be a curve like that. Then you have another curve also from this one, supposed to be a curve also that you're going to use to part this part, then like this, something like this. All right, so that is what they needed you to actually sketch, to draw. So you mark the points there properly. After marking the points, then you join them. Okay, so you're just given 2 points. It's something else, but that's what they actually needed you to do. All right, so on 7, okay, this is actually on question 5. So this was for question 5, this one question 5. Okay, so that's what we had on question 5, and I'm seeing another one. This one is for question 7. Okay, we'll see it, but it's for question 7. Let's see what we had on question 6. Yes, something that was a pretty question again that we had on question 6, where we are given to complete the following sentences by writing only the missing words, word or words next to the question in 6.11. Okay, lines that intersect at 90 are, okay, so this is not like 9, it's 9, it's supposed to be 90 degrees. Okay, so the lines that intersect at 90 degrees, they are perpendicular. Okay, so these ones, they are perpendicular. Where do we get this rule like this? When two lines intersect at 90 like that, they are perpendicular. Okay, so these ones, they are perpendicular. They are perpendicular to each other. An angle that is formed outside an enclosed shape between the side of the shape and a side that has been extended is n. All right, you're given a closed shape like this, then you extend one of the line like this. The angle that is between, which is outside of the shape, this one is called an exterior angle. That's an exterior angle. So that was the one that you needed, exterior angle. Find the values of A, B, and C. A, B, C, and D from this part. Okay, so you've got the value of A, the value of B, the value of C, the value of D. All right, so which concept can you use? As you can see, these are actually parallel lines. These lines, they are parallel. This line and this line, they are parallel. This one, these ones, they are parallel like that. So these are parallel lines. Okay, and also we can see that here it's a straight line, so we can take advantage to calculate the value of A because we have got angles on a straight line, and we know that angles on a straight line, they add up to 180 degrees. Okay, so we can take that as an advantage. Okay, 6.2. So if angles on a straight line add up to 180, we can formulate an equation. If we add these two angles, they are going to give us 180, which is A plus 20 plus, this one is 2A plus 10. So it's 2A plus 10. We must obtain 180 like that because it's a straight line. So we have formulated an equation. We can solve for A. So it's A, which is 1A plus 2A. So it's 1 plus 2, which is 3. 10, 20 and 10 there. If you add this properly, it's going to be a 30 there, which is going to give us a 180. All right, so what are we having at the end? 3A is equivalent to, you can transpose this 30. It's going to be a minus 30. So we've got 180 minus 30, which is actually a 150 there. So to obtain A, you can divide, just divide by 3. So your A is going to give you something like a 50 degrees. So A is 50. So if A is 50, what does it mean, guys? It means this part here you can actually substitute because your A is 50. So 50 plus 20, which means you're going to obtain 70 degrees. So this angle is 70. So if this angle is 70, I can actually take advantage of that to calculate this value of B here, and also to calculate this value of D. Why are we saying so? Because we know that if these two lines are parallel, from the concept of parallel lines, you know that from the concept of parallel lines, when these two are parallel, these are co-interior angles, and they give us 180 degrees. So to obtain B, it will be 180 minus 70 to find B. From this concept here, if you're given parallel lines like this, okay, these two angles, they are co-interior angles, they add up to 180. So if you want to find one, you simply subtract from 180. Okay, so which means your B is going to be 180 degrees minus 7. Take note, it's 7 because we said 50 plus 27, so this whole angle is 70. Okay, so you're going to obtain 110. So your B is going to be 110. Okay, so if our B is 110 here, what about C? B and C, they are also together like on a straight line like that, or you can just have to extend this. As you can see, if you extend this part, you've got Z angles which you can use. If this angle is 110, this angle is going to be 70 also from a straight line, or you just subtract 180 minus 110, which is going to give us 180. So C is going to be 180 minus 110, which is 70 degrees. Okay, so you've got the value for C. What about D? D, we can also use the same concept, because here we've got 70 here, and these two lines, they are also parallel. So it means this D is going to be from 180. 180 minus 70, which is 110, just like what we did for B. So our D is going to be the same, 180 minus 70 degrees, which is 110. Why? Because they are corresponding angles. They are co-interior angles. They are inside the parallel lines, and if they are inside the parallel lines, it means that they must add up to 180 degrees. So this is a concept that you work with actually when you are having parallel lines. So that's it, guys. As you can see, it's an application of questions on parallel lines and so forth. So you can actually consider working with match questions and so forth. So we are given on question number 7, if tan beta is equal to 6/8 and beta is an element from 0 to 90, that is the interval from 0 to 90. We know that from 0 to 90, that is the first quadrant. Okay, simplify the following: sine beta, cos beta plus tan beta. All right, so what they actually need you to do in this case, first you can represent this in the quadrant. We are given that tan beta is equivalent to 6/8. Okay, so do not reduce this value that you are given. You can just use this value as it is. Yes, you can reduce, but just use this value as it is. Okay, so you are given that beta is an element of numbers from 0 up to 90. That is the interval. So which means this beta ranges from 90 to 90 degrees. So it is in the first quadrant like this. So you're going to have your beta in the first quadrant. All right, so this is what you're going to have in this case in the first quadrant like this. All right, so this is going to be the angle beta like this. All right, so according to tan, remember from SOHCAHTOA, we know that tan is opposite over adjacent. So this is your opposite over adjacent. All right, so if it is the opposite, according to this beta, this is the opposite side, because this one is going to be a 90 degrees, and this is the opposite 6. This is your opposite, and the adjacent, this is the adjacent, which is 8. All right, so definitely by looking at this triangle, you are forced to calculate the third side, because you do not have this side. So what can I use to calculate the third side? Definitely I'm going to use the Pythagoras theorem. This part you are given it in your formula sheet for triangles. When you are given two sides like that and you want to calculate the third side, you can actually apply the Pythagoras theorem. All right, so this is the part that I'm talking about here. You're actually given this Pythagoras theorem. Okay, when you're given two sides, you want to calculate the third side, you can use theorem of Pythagoras, which is c squared is equal to a squared plus what? Plus b squared. So you can actually apply this concept. All right, so let's start by calculating that side. If c squared is equal to a squared plus b squared, our c in this case is the hypotenuse, the one that we want to calculate. All right, so c squared is equal to a and b. These are the shorter sides, so you can say this is your a, this is your b. All right, so you're going to have 8 squared plus another side, which is 6 squared. All right, so let's see what you're going to have. So from our calculator, c squared is equal to 8 squared, that is 64, plus 6 squared from our calculator, that's 36. All right, add everything you are going to obtain a 100 in this case. Then to find c, this is squared, so you introduce the square root both sides, so c is going to give you a 10. That is this side here is 10 units. All right, so now let's cross check what we have on our question here. If you are to cross check, we need sine beta, we need cos beta. Tan beta is already there, but we need sine beta, cos beta. So let's find these ones. Okay, so we are going to find the value of sine beta. Okay, but from this part we said sine, that's opposite over hypotenuse, so it's going to be opposite over the hypotenuse. Okay, and what is your opposite in this case? This is your opposite 6, your hypotenuse is 10, so you've got 6 over 10. That's your sine beta. Okay, so let's just leave this. We move on to cos beta. We do the same again because we need the value of cos beta. All right, so let's find the value of cos beta. Cos is adjacent over hypotenuse, so it's the adjacent here over the hypotenuse. This is your adjacent. According to this beta, this is your opposite, this is your adjacent, and that's the hypotenuse, the longer side, which opposes 90 degrees. Okay, so adjacent 8 over 10, so you have 8 over 10 like this. All right, so you have the value of cos, the value of sine. So now we can simplify the expression that we are given to simplify on 7.11, which states that we need to find the value of sine beta. Remember that it was sine beta cos beta like this plus tan beta. This is what you're given to simplify. So it's now a matter of substitution. Let's substitute. Sine beta is there, is 6 over 10. 6 over 10 multiplied by cos beta. Your cos beta is 8 over 10. So you've got 8 over 10 plus, you take note there's a plus there, so it's plus tan beta. Already tan beta is the one that we were given before. If you still remember, we were given this value of tan beta here, which is 6 over 8. All right, so we are given this value, which was 6 over 8. All right, so you can actually use your calculator to simplify this value that you are given, which is very, very important for you. So how am I going to simplify is very, very important. I'm going to start with them. You can start with these two, multiply these two first. If you multiply these two numbers, you're going to obtain 12 over 25 plus 6 over 8. All right, then we add 12 over 25. If we add this 12 over 25 plus 6 over 8, we are going to obtain 123 over 100. So you're going to obtain 123 over 100. All right, so this is the value that we are obtaining if we could have simplified this properly. So you just cross check, guys, on your calculations and working, but that is what you were asked to do. All right, another part is 7.12, still a continuation from the same information, but this time what are we determining? We are given on 7.12 to determine 4 plus sine 90 degrees plus sine squared beta like this plus cos squared beta like this. All right, so what am I going to do? We are going to substitute here. So for there's nothing that you can do, you just substitute. Okay, plus sine 90, this one you can just use your calculator to find the value of sine 90, which is a 1. So sine 90 degrees from your calculator, that's a 1, so you're going to have a 1 there, so you're going to add 1. All right, when you are given an expression like sine squared beta like this, it means the same thing. Sine squared beta is equal to sine beta squared like this. It's one and the same thing. So remember, we have the value of sine beta. We calculated this, or we stated this value of sine beta before. Let me show you. This is your sine beta here, which was 6 over 10. So it's going to be 6 over 10 squared like this. Okay, so from your calculator, let's see what you're going to have. 6 over 10 squared, just open a bracket there, 6 over 10 in bracket, then square the bracket, that's 9 over 25. 9 over 25. Okay, we move on to cos squared beta. We do the same, is the same as cos beta squared like this. Okay, so what is the value of cos beta? We obtain that it's 8 over 10. Okay, so it's going to be 8 over 10 squared like this. Okay, so let's obtain the value. Just change here to 8, just change the 6 to 8 is going to be 16 over 25. So you've got 16 over 25 like this. All right, so you have the value of sine squared beta. So now we can substitute here sine 9 to obtain 1. Sine squared beta, this is your sine squared beta here, which you obtained is 9 over 25. So it's plus 9 over 25 plus cos squared beta. We obtain the value of cos squared beta here, which is 16 over 25. 16 over 25 like this. All right, so you can add up everything using your calculator properly. So what is important, guys, is to apply your calculator properly. In this case, you're going to obtain something like 6 if you add properly there, because this is going to give you a 1. All right, so you're going to obtain a 6 there. So that was it on this part. That's how they can actually ask this question. All right, so let's see the other part, which was to sketch the graph of f of x on the answer sheet 2 attached. Okay, so I want to sketch the graph of y f of x is equal to minus sine x plus 2. How can we sketch this graph, guys? How can we sketch this graph? F of x is equivalent to minus sine x plus 2. Okay, so for you to sketch this graph is very easy. You cross check on the table that you are given on the graph that you're supposed to draw this. Okay, let me show you the part that you're supposed to actually sketch this. This is the sketch here. So if you are to cross check, you've got angles 0, 90, 180, 270, 360. So these are the values that you're going to use for x. These are the values for x, and these are the values for y. You've got minus 0, 0.5, minus 1, 0, 0.5, and 1. So what am I going to do? I can just have my table here. Y is equal to minus sine x plus 2. Okay, so you just have a table. So on this table, you are going to have the values of x and the values of y. So the values of x are the ones that you are given here from 0, 90, 180. Just substitute them. So you've got 0, 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. So this is the interval that we have from this graph. So there is a matter of applying your calculator properly. Make sure that your calculator is in degrees. So the first part is when sine is 0, so it's minus sine 0 plus 2. Okay, so I'm obtaining a 2 here. Okay, another one, it's minus sine 90. Minus sine 90 plus 2, you substitute. So you're substituting 90 in place of x like this. Minus sine 90 degrees plus 2. You're going to obtain 1 there. You move on to 180. You do the same. You substitute 180 there. It's going to be 2. At 270, you do the same. 270 there. You do the same. This is 270, not 2000. 270. You're going to obtain a 3. You move on to 360. 360, you obtain a 2 again. All right, so these are the values that you're going to obtain, guys. But if you are to cross check, guys, on this part that we are given with the graph that we have and the information that we have, doesn't make sense, because here we are given from 0.5 up to 1, and these values, they're actually more than that. So it's actually something that you are supposed to consider in exam, such type of typical errors. So this is minus sine x. So there's no way, guys, we can obtain these values because, okay, I want you to cross check here. Are you seeing that the maximum value is for y there is 1, the minimum value is minus 1? So there's nothing that can actually come out because our values, they are greater than. But it was supposed to be like this. Let me show you, because that sketch, the graph that we are given, it's not applicable at all. It's not applicable at all, but your graph was supposed to be like this. Let me show you what was it supposed to look like. 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360 degrees. All right, so you've got 1 up to 3. So you've got 1, 2, 3, minus 1, minus 2, minus 3, like that. All right, so you just mark your points like that. So this is the values for y, and these are the values for x. Okay, at 0 there, y is 2. So you've got 0 versus 2. So you mark your point at 0 and 2. Okay, at 90, 90 and 1. So it's 90 versus 1. This is your 1. You mark your point at 1. 180. 180 is versus 2. So it's 180 and 2 at this point here. 180 and 2. So it's 180 versus, supposed to be versus 2. Okay. Let's move on to 270. Okay, sorry for that. Let me just adjust this side. Okay, 270 is 3. Okay, that's 270 here, which is 3. So 3 is at this point. So 270 versus 3, something like this. Okay, you mark your point. Then is 360 versus 2. 360 versus 2, which is these 2 that we had here. So these are the points that we're supposed to join like this. So it's a sine graph like this, supposed to go like this. It goes like this. All right, so this is how your graph was supposed to actually look like. But because of the scale that we are given there, the values of x and the values of y that we are given, we can't have this. Maybe it was just an error. Maybe we're supposed to be having, maybe if it was minus sine x minus 2, yeah, maybe that way it was going to work. Or maybe just sine x, because we know that the range here is not applicable. All right, so but that's what we had from this information. So guys, these are some of the things that you are supposed to get rid of and manage to locate them in exam, because they can be a consideration or a part like that where you are now forced to look back or cross back from what you are given. So sometimes it can be like that. You have to be very, very careful anyways. All right, so that was actually number 7 there. And on number 8, we are given to calculate the radius of a circle with a circumference of 54 centimeters. Okay, calculate the radius of a circle. Okay, so how can I calculate the radius of a circle? Remember the properties of a circle. That's the radius of a circle. And when I'm given the circumference of a circle, I can calculate the radius. Why? Cross-check here on the circle. I want you to cross-check something on the circle here. The circumference of a circle is given as 2 pi r there. So as you can see, already the radius is there because we are given the circumference. Okay. So if the circumference of a circle is equal to 2 pi r like this, I'm just going to substitute the circumference that I'm given, because I'm given that the circumference is 54 centimeters. So 54 is equal to 2 pi r like this. So to find r, divide by 2 pi, divide by 2 pi like this. So I'm going to cancel this. So r is equivalent to 54 over 2 pi. Okay, so it's going to be 54 over 2 pi like this. Okay, so from your calculator, if you are to simplify this value properly, you are going to obtain 8,593,66927. All right, which you can round off to 3 decimal places, which is going to be 8,123. So 3 cannot change 4, so it's going to be 594. Okay, the units of the radius, you are going to take them from the circumference of a circle that you were given. So what was the circumference in? It was in centimeters. so this radius also is supposed to be in centimeters. Okay, so these are the units that you're going to take. So that was it on 8.1. The radius of a circle given the circumference, we just substitute into the formula and find the value of r. All right, on 8.2, you're given that given parallelogram A, B, C, D. Take note, this is a parallelogram, and we know that for a parallelogram, these sides, they are parallel, and also these two sides, they are parallel. So their opposite sides are parallel and equal. So these are parallel, and at the same time, they are equal, parallel and equal. All right. We are given that BE is equal to 3 centimeters. This BE is 3 centimeters. EC from E to C is 8 centimeters, and DC is 5 centimeters. But remember, we said these are equal. So if DC is 5, it means AB is equal to 5. Okay, and if we are given BE and EC, if you combine these together, 3 plus 8, that's 11. So which means from B to C, it's actually 11, which means it's the same thing from A to D, it's also 11. Why? Because opposite sides are equal and parallel for a parallelogram. Okay, so the first question is to calculate AE. Calculate AE. Okay, let's cross check. This is our AE here, and this is a perpendicular line. When it is perpendicular, it means also here it's 90 degrees. So I want you to remove this triangle here, ABE. This is a right angled triangle. So let us remove this triangle. Let us separate this triangle like this. I want you to see it is going to be clear now. This was your A, this was your B, and this was your E from the actual diagram. This one, we removed this triangle here. So as you can see, this is 5 and this is 3. So you've got 5 here and you've got 3. And the question is asking you to calculate AE. Guys, just look at this question. Calculate AE now. Are you seeing that it's just a right angle triangle? So you can apply Pythagoras theorem to calculate what? To calculate AE, where we know that C squared is the hypotenuse, which is the longest side, which is 5. So 5 squared is equal to A and B. These are the shorter sides, which is this 3, and this unknown side that you want to calculate. Okay, so you can just say A squared plus 3 squared. Okay, 5 squared from your calculator, that's 25, which is equal to A squared plus 3 squared from your calculator, that's 9. So you can transpose this. Is going to be 25 minus 9, which is equal to A squared. Okay, so what is 25 minus 9? This is 16, which is equal to A squared. You want to calculate the value of A, square root both sides, square root to remove this square. So A is equal to square root of 16 from your calculator, that's 4. So it means this side AE is 4. Okay, so therefore our AE in this case is equivalent to 4 centimeters. That's what we obtained. Okay, so that was it, guys, on 8.21, where you were asked to calculate the value of AE, or the length of AE, the length of a right angle triangle. So if you're given a right angle triangle, the length simply from Pythagoras theorem. All right, then calculate the area of the parallelogram. All right, so also you're supposed to know these formulas, guys, and how to apply the formulas if you are given such type of a question. So what are we going to do? That's the question now. What are we going to do, or how are we going to apply this? There are so many options that you can do. If you are given a trapezium, a parallelogram like this, you can actually use the concept of the base times the perpendicular height to calculate, because AE is now there is 4 centimeters like this. So when you are given a parallelogram, guys, for a parallelogram, when you are given a parallelogram, the area of a parallelogram is simply the breadth. Let's just say breadth times the perpendicular height. Times the perpendicular height. We know that area, remember, area of a triangle is half base times perpendicular height. But this one, it's base times perpendicular height. Okay, so the base in this case is this longer side, this base here, which is B to C. So it's B to C, which is 11 centimeters, because we said 11, 3 plus 8, which is 11. Okay, so it's 11 times the height, which is the perpendicular height. The height of the parallelogram is this side AE, or this side here is the same thing, this is the same height. If this is 4, this is also 4. So you multiply by the height of the triangle, which is what? Of the parallelogram, which is 4. So if you multiply by 4, you're going to obtain 44. And this is area, which is measured in square units. So it's going to be square centimeters. All right, so that's it, guys, for this question. John and Mary are expected to share 2 million rand in the ratio of 2:3. How much will each get? How much is each going to have? Okay, when you are given a ratio like that, it means you find the total ratio. The total ratio, which is 2 plus 3, so total ratio is equal to 2 plus 3, which is equal to 5. So this total ratio of 3 is the one that is equal to 2 million. So which means John is going to get 2 out of 5. Okay, so John is going to get 2 parts out of the total, which is 5, times the amount which they shared. They shared 2 million rand. All right. So what is going to be the amount there? So what is important is to use your calculator properly, guys. There is nothing that is important than to use your calculator properly. Okay, so 2, you are going to obtain 800,000 here. 2 or 5 times this is going to be 800,000. All right, which is the same thing for Mary. Mary obtained a ratio of 3. So it's going to be 3 over 5. Okay, so this is for Mary, a total of 3 over 5. So this is 800,000 rand times 2 million rand. All right, a lot of money actually. So using our calculator again, this is now a ratio of what? Of 3. So you are going to obtain something like 12 here, which is 12 there, which is 1,200,000. Yeah, 1,200,000. It makes sense, something like that. All right, so this is the amount that Mary is going to have. So it's just a matter of you applying or using your calculator, and you got 3 marks for that, guys. So that's it, guys, making a total of 100 from this question paper. So actually, when you are working with anyone, as you can see, guys, it's a matter of applying formulas properly and the questions properly. As you can see, it's nothing at all. It's nothing at all. This whole paper is nothing at all. What you need is to be very, very focused in whatever way that you are doing your work. You must be very, very focused, and also know how to apply the formula sheet whenever there is a need for you to apply anything from the formula sheet. You must know the application of the formula sheet, and also how to use this right angled triangle. It's very, very important. And last part, how to also apply or use every question as it is given. Each and every question that will be given, how you attempt the question is very, very important. So that's it, guys. Working on engineering, that is working on mathematics N1 from Maison African Motives. So if you are new to this channel, or your first time to be part of the channel Maison African Motives, guys, you can consider subscribing so that you won't miss any of the classes that we shall be having from Maison African Motives, working on mathematics N1 revisions and question papers from the Department of Education that we are having, that is working with netted engineering. So that's what we have, guys, from Maison African Motives. Till we meet again.